you see, to determine the quantity of mortar and the volume for per brick of the mortar required for one brick in cubic inch equal to T times W times L plus H plus T. What is T? The joint thickness. So that is the mortar thickness in inch. And W is the brick width or depth that I talked in the previous problem. H, brick height, and L is brick length. So let me show you why we have that equation to determine the volume for mortar for one brick. TW times L plus H plus T. So go to the slide that we have in today's class. So you have, if we put one brick, we need the mortar. Let me consider this brick. Okay, and then the mortar for that brick is, we have to put the mortar from here to there, and then the mortar in this side, and similar you keep laying for the next brick it will have. So as you can see, the length of the brick here is L, and then we have the thickness T, and we have the brick height. This is brick height H. So the basically it go from L plus T plus H. So that's what we have for the last component, L plus H plus T. And then we have the width. The width, which is for one brick, the width, it will be here. This is W. So we have to get inside, okay? And then that is the two dimension. We have the H plus L plus T that go through for one brick. And we have to time the W, which is the width, and the thickness of the mortar, we have time T. And that's what we have for that equation. To be more visual, I just show you a picture here. So at this picture, you see to have that laid out, we need to have the mortar in these areas, as you can see there, and then the have the mortar on one end. So that's why we have for two already laid out the mortar in there and the other mortar there. So that's why we have that equation in. And let's apply that in problem 4. Estimate the quantity of mortar required for the problem 2. The problem 2 we did before. And this should be a problem 3. So that should be problem 3. And the joint between the width is 0.5. Assume it's 25% waste factor. So first we need to find out the volume per brick, volume of mortar per brick that we have in that previous equation. So volume per brick. And we already have that equation previously. So it equals to 0.5, the thickness, time that same bricks that we have in problem 3, which is the width 3.75, the height 2.25, and the length is L is 8. So you have that is the width 3.75 and time, the length 8, the height 2.25, plus the thickness of the mortar 0.5, and we have to convert that into cubic feet. That will be a cubic inch if you want to put it in cubic feet. So you will have to divide by 12 power 3, right? 12 power 3 to convert unit in cube over cubic feet. So from that one, we will have this equal to 0.01166 cubic feet. That's the equation we have. And then when we have the volume per cubic for mortar per brick, we need to find out the how many bricks do we need. And as you can see, we already find out in the previous problem for the number of bricks for 2 width. We need to find out for each width first. Each width. So we have to divide. So the number of bricks for 2 is 982. So the one width, it have to divide by 2. So from that, we can determine the volume per width. And for problem per width, it will be equal to, for one width, we need the mortar 0.01166 cubic feet. And for one width, we have 892, that is the total bricks for both double width divided by 2, because we have per width. So from that, we have 5.7 cubic feet. 5.7 cubic feet. And we need to find out the volume between the width. As you can see, the mortar also between the width in here. Between the width, we have the mortar there. So it will be equal to the areas, the net area, times the thickness. As you can see there, between the width. So from that one, we need to find out the volume of mortar between width. And that equal to the thickness times the net areas. The thickness of the mortar, go back here. The net areas we find out in problem 3, and the thickness of the mortar between the width. That the problem with us is the joint thickness between width is 0.5 inches, and the problem give you. So 0.5, and because cubic feet, so we divide by 12 inch over 1 foot. That is unit conversion. And time the net areas that go to the problem 3, and that is 77.33 for the net go areas. So from that one, we have time 17.33. So that is feet, square feet, then become cubic feet. So 3.2 cubic feet. Then we have the mortar required per width, volume of mortar between the width. So we can be able to finally determine the mortar required for the whole goal, double width goal. And it equal to, per width, 5.7, and it double, so we time 2. This for double. And then we plus volume between width 3.2. And with that, we have to time the weight 25%. So you have time 1.25 for the waste. And the waste of mortar is more, you can see 25% compared to bricks 3%, which makes sense. So it's 18.3 cubic feet. So that is the answer. What is the volume of mortar required for this problem? And again, this is problem 3, not